Hi, you guys. Today I have problem 5.14 from Young and Freedman's University Physics textbook. Before we get started on this problem, please don't forget to like and subscribe if you find my videos helpful. Thank you so much. Okay, so three sleds are being pulled horizontally on frictionless horizontal ice using horizontal ropes. The pull is of magnitude 190 newtons. Find A, the acceleration of the system, and B, the tension in ropes A and B. Okay, so we're lucky because we actually have a diagram to accompany this problem, but we're going to go ahead and actually draw like subsets, or I guess like a force body diagram of this, or multiple force body diagrams of this diagram. Okay, so we have three sleds and they each have a different mass, right? So let's just call this like red R for red, yellow, and then orange, right? Um, and we can go ahead and draw the diagram. Actually, first, let's actually start with the knowns because we like the diagram's already drawn. So what are we going to do? We have to write down the knowns first. Okay. I think I might need to change my pen thickness. So give me a second. Okay. No, sorry. I really don't like that. So knowns. Okay, cool. So what do we know? We know the force that's being used to pull this system, and that's 190 newtons, right? We are looking for the acceleration, but we don't have that. And then we also have mass of the red sled, which is 30 kilograms, right? We have the mass of the yellow sled, which is 20 kilograms. We have the mass of the orange sled, which is 10.0 kilograms, right? And that is everything. Okay, cool. So we are looking for the acceleration. Well, when we do the analysis of this problem, right, we know that if we're looking for the acceleration of this system, right, that is going to be equal to the acceleration of the red sled, right? And that's going to be the same acceleration as the yellow sled, as the orange sled, right? And that makes sense because obviously, if you're pulling something and the ropes are taut, it's all moving at like the same speed, the same acceleration. It has the same motion. So this is really intuitive. Okay, but if we want to find the acceleration of the system, how do we do that? Well, we know that force is equal to mass times acceleration. So the force that we're pulling this system with, right, divided by the mass of the system is going to be the acceleration of the system, right? So I'm going to do like cis, cis, and then cis, right? So if we want to find the acceleration of the system, we just have to do force divided by mass. And that is just 190 over 30 plus 20 plus 10. And that is 190 divided by 60, which gives us 3.167 meters per second squared. Okay, cool. So now part B. we have the acceleration of the system. Oh, so part A, we have the acceleration of the system. Now part B, the tension in ropes A and B. Okay, so now for this part of the question, we actually do want to go ahead and draw like individual force body diagrams for each sled, right? And what do I mean by that? Well, what I mean is that we want to draw a diagram of all the forces that are acting on each sled, right? So let's start with the red one. We have, of course, force of gravity, right? And then we also have normal force, right? Because the sled is in contact with a surface, which is the ice. And then we just have, this force of tension, B, right? Because of this rope, right? And those are all the forces that are acting on this box. That makes sense. Okay. And maybe we can just go ahead and make it clear that this is the 30-kilogram box. Okay, now let's do the same with the yellow sled. I don't know why I said box, sled. Okay, same thing with the yellow sled. We have FG. We have FN. This time we have FTB in the opposite direction. And then we also have FTA. So we have the force of tension of rope A and B, right? And then the mass is 20.0 kilograms. Cool. Okay, and then now for the last sled, the orange sled. Let's go ahead and draw that. FG, FN, FTA, right? Because the force of tension is going to be in this direction. And then just F, right? So the pull, which is F right over here. All right. And mass is 10.0 kilograms. Okay, so now we are looking for the tension in ropes A and B. Okay. So yeah, we're looking for the tension in ropes A and B. So what we can do, actually first, the first thing that we should do is just go ahead and label our like coordinate system. So this is going to be positive X and positive Y. That's what I've set it as. Okay. So now what we want to do is we want to go ahead and write down the summation of forces in both the X and Y direction, right? So yes, it's kind of useless to do the Y direction because we know that there's no motion in the Y direction for like any of them, right? So like Fn and Fg cancel out for every single sled, obviously, because there is no motion in the Y direction. The sled's not moving up or down. But just for sake of completeness, I'm going to include it just so that we really understand what's happening in the problem. So Fy is equal to Fn minus Fg, right? Because n is upwards, like we said, that's positive y, right? Positive y. So Fn minus Fg, and that is equal to 0. Obviously, there's no net force, there's no motion, there's no acceleration. And then now let's do it with like in the x direction. So the summation of forces in the x direction, which is FA. So just to make this clear again, we are talking about this orange sled right over here, right? So this doesn't really matter. This could apply to like all three of them. This could be for like red, orange, or yellow. But for X, this is going to be, you know what, I should actually do it in orange just so that it makes sense. Okay, so the summation of forces in the X direction, that is F, right, positive F minus FTA. And what's that equal to? That's equal to the mass of the sled times the acceleration of the sled, right? So mass of orange times the acceleration of orange or the system really doesn't matter, right? Because we said that orange and the system are going to have like the same acceleration. And so we want to isolate for the tension in the ropes, which is FTA. So if we rearrange, FTA is equal to F minus mass of orange sled times acceleration of orange sled. Okay, so FTA is equal to 190 minus 10 times 3.167. And you can actually leave this as like 3.1666667 on your calculator because that's way more accurate, obviously. Um, but, and that's what I'm going to be doing because you can just store your like answer in your calculator. And what I get now is that FTA is equal to 158.33, 33 newtons, right? So you can actually rewrite newtons. And the reason I did this is just because, again, like I'm gonna eventually get to the comments, but I saw someone asking about like, do I usually use sig figs in my solutions? And the answer is no. I really just focus on like getting the right answer, and then I trust that you can probably do the sig figs yourself, depending on like what you're used to. Because I know that the rules like slightly vary depending on like which like school you go to, which like college or university you go to. Okay. So there we go. We have the tension in rope A. So now we have to go ahead and do the tension in rope B. Okay. And so we can actually go about this in like two ways. And so interestingly enough, well, not interestingly enough, I guess if you, this is one of the problems where if you like round your answer early on, you're going to end up with like a slightly different answer depending on if you use the red or yellow sled to solve for FTB. But you know what? I'm gonna go ahead and just we can go ahead and actually do both. We can do both. Okay. So now let's use the yellow sled. So summation of forces for the yellow sled in the x direction is what? This is FTA minus FTB is equal to MYAY, right? So the difference in these two forces is going to be the net force, which is MYAY. So let's go ahead and plug in our values. We have FTA right over here. So that's going to be 158.333, on and on, minus FTB, which we don't know, and MYAY, that's going to be 20 times 3.167, right? And we can isolate for FTB. We should have actually done this earlier on. It would have been like FTB is equal to FTA minus MYAY. Okay. And that is equal to that is equal to FTB is equal to 95.0 newtons. That's what I'm getting, right? And what did I mean by we can do it both ways? Well, we can solve through using like the yellow sled, and we can also solve FTB using like the red sled, right? So how do we do that? I'm just gonna go ahead and erase like this part right over here, and we're gonna resolve. Just obviously like we've already solved it, but I'm just doing this for sake of like for the learning, just so that you can do it both ways. And the red one's actually a little bit easier. And why do I say it's easier? Well, let's show you how it's easier. So if we write down the summation of forces in the X, right, we have just FTB. So FTB is equal to what? The mass of the red sled times the acceleration of the red sled, right? And FTB is equal to MR, which is 30, times AR, which is 3.166667, which again is 95.0 newtons, right? So we solved it either way. FTB is equal to MRA, and that also gives us 95.0 newtons, right? So that is our answer for part B. We solved for the tension in rope A. I'm just gonna highlight that in like a different color. Let's highlight that in purple. Yep. So we have that. And then we also have FTB is equal to 95 newtons. There we go. That's our solution. I hope that was helpful. If it was, please don't forget to like and subscribe, and see you next time. Thank you so much for watching.